All right, and if you're good with this one, then just go ahead and get started on the 14.2 stuff, you know? Use your time. All right, so number 10, this is the fraction of AG problem. So it says a uniform solid sphere of radius r, uniform solid sphere of radius r, produces a gravitational acceleration g at its surface. At what distance from the sphere's center are there points inside and outside the sphere where the gravitational acceleration is g over 3? Okay, so let's do outside the sphere. All right, so yesterday, remember we talked about the fact that to calculate the gravitational force between two things, it's g times the mass of the bigger thing times the mass of the littler thing times the distance between their centers squared, right? So how do we then use that to derive the acceleration of gravity at a given point? You divide by the little m, right? So that means that our acceleration of gravity at a given point is g times capital M over d squared, right? Cool. So what this is telling me is it's telling me that g is g times m over capital R squared, right? And the question wants to know g, oops, that is not how you make the letter G. Newsflash. Not that that is either, but deal with it. So the question is, at what distance d will the acceleration be g divided by 3? Yeah, sure.
I just want to make sure there's not a difference between d squared and r squared, right?
Correct, yeah. Yeah, sorry, I'm sloppy about switching between. Yeah, d's and r's. It's. Although in this problem, the capital R is a fixed value, right? Right here, capital R represents the radius of this planet that the problem is about, right? And capital M represents the mass of that planet. Everybody good up to there? All right, so the question is, what fraction of R does D have to be to make this G over 3? Well, I don't know how you guys go about solving these. I guess you could multiply both sides by 3 and set them equal to each other, right? So this is the same as 3gm over d squared, right? Multiplying by 3. Cool. And then your gm's cancel. So now I'm looking at 1 over r squared equals 3 over d squared. We're trying to solve for d, right? So d squared is 3r squared. Square root both sides, and d is root 3 times r. There are certainly other ways about going about that process, but that works. Everybody good up to there? Okay, now doing inside the planet, there's a trick that I showed you in the video. You have to remember this trick. It's a result of the shell theorem. All right, here's the trick. So what the problem tells us is you're given a planet with mass m, and you're told that it has a radius of capital R, and that at the surface of the planet, the acceleration of gravity is g. Okay, and so the question is, if I dug a tiny little hole somewhere in the middle and lived in that tiny little hole, where would the hole have to be for the acceleration of gravity in that little hole to be g over 3? All right, so here's the trick. So inside a sphere, the force of gravity is g times the mass of the planet times the mass of the object, your mass, divided by r squared. And then it's just times the radius that you're at from the center divided by the radius of the whole thing. So in other words, if you're halfway out, you're going to have half of the force of gravity. Follow? All right, the proof behind this is a little bit more involved, but I showed it in the video. Cool. So Where do you have to be for g to be g over 3? I said that wrong. Where do you have to be for the acceleration of gravity to be g over 3? A third of the radius. So 1/3 of capital R. Cool. Hey, how are you? Look out, don't put your eye out on the teeter-totter. Yes.
Are they here?
Yes.
Okay.
Excellent. I will deliver it.
Thank you.
You are welcome. Hello.
Oh,
Winning. Oh, busted! She's even got her little pencil case set up in front of it, so they won't notice. It's very sneaky. All right. Is everybody good with this? All right. Anything else on that homework assignment that you guys would like me to go over?